Welcome to section 5.2, area under a curve. We're going to begin with discussing the integral sign. And what you have right here is this entire symbol is read as the integral of f from a to b. Now, each part of this integral has its own name, and so this is something that you need to learn. You will be quizzed on this. The S, the elongated S. This is called the integral sign, and it is another notation for sigma because an integral is another way to notate a sum. Now, the A and B, this is the domain. You will start your graph at A and end it at B. A is called the lower limit. B is called the upper limit. This is a higher number. F of x, this is a function. It's called the integrand because you're taking the integral of it. And then x is the variable of integration. You need to learn each part of this. This will be on a quiz for you to label. Now the dx, you may be wondering. The dx is a sign that you have taken the derivative of a function and gotten f of x as your answer. So that is where the dx comes in. Now, to talk about area under a curve, what we're going to be doing is looking at the integrals of several variables, several common shapes that we easily know the areas of. The first thing that you need to do is graph whichever shape that we're dealing with. And when you graph this one, what you're going to find is that this is a semicircle of radius 2. See? That 4, that's r squared. Now a semicircle, well, a whole circle has the area of pi r squared, but a semicircle has the area of 1/2 pi r squared. So all we simply have to do is substitute in our radius of 2, and then we know that our answer is 2 pi. Now the negative 2 and the 2 right here, they show me that I am going to be looking at that entire area. That's very important. But if there was a change and I decided I only wanted to look at 0 to 2 of the same graph, well, I wouldn't start at negative 2 right here. What I would do is start at 0 right here. So I'd start at 0 instead of 2, and that's half of the semicircle, so its area would be pi. Another common shape that we use is the triangle, and x minus 1 is graphed like this, and it tells me to start at 1, which is here, and end at 4, and we'll call that 4. Well, the area of a triangle is 1/2 base times height. Now, the base is just how long this triangle is. That would be 3. Well, I don't know how tall this is, but I do know that if I substitute So for this problem, I graphed x minus 1, and I see that my area that I'm wanting to evaluate is this triangle right here. So 1/2 base times height. How I found the height right here is I did f of 4 and substituted that into x minus 1, and that's 3. And to find out where the y value was down here, I put in 1. So here's my base, difference between the 1 and the 4. Here's my height, the value of 4 plugged into the function. Another common shape that we use is a trapezoid. So the first step, graph the function. Well, it crosses at 1, has a slope of 2. And I'm going to begin at 1. So here's my 1. I'm going to end at 4. So here's my trapezoid. And I know it's a trapezoid because we have 2 parallel lines, one right here, parallel line right there, and one right here. And so those serve as my bases. Now, the area of a trapezoid is 1/2 the sum of the bases times the height. Well, we're used to our bases being the horizontal, but this time it's not. Here, this little segment right here, that's the height. This vertical, that's B1, and this one is B2. So how do we find out how high this is? Right here. Well, we're going to substitute 1 into our function. And when we do that, that gives us 3. And then we're going to substitute 4 into our function to get our other height, and that gives us 9. And our height is the difference between these two, so that's 3. So we're just going to substitute this in, add the 2 bases, that's 12. The height is 3. And that gives us an area of 18 units squared. Well, this is part of a larger concept. We're talking about area between a curve and an axis. So if you see this symbol, this is the area you just evaluated. But there's the condition on this. This is if f of x is greater than or equal to 0 on a closed interval from a to b. This is above the x-axis. But most of the time, our curves don't stay above the x-axis, so what do we do then? If the function goes below the axis and becomes negative, then area is equal to the negative integral of f of x dx. And if f of x crosses the axis on its interval, then area equals to area above minus area below. So essentially we're taking the absolute value of the value that's below the x-axis. So the first integral that you're going to learn to evaluate is that of a constant. Now a constant, this is a number. So if you remember the problem where we were talking about the drive down the interstate at a constant speed, not changing for a couple of hours, what we ended up doing was multiplying that velocity by the difference in the time, which is basically what we're going to do here. So your rule for the derivative of an integral, wrong semester, integral of a constant is to take that c, that constant, and you're going to subtract the b and the a and multiply it by the c. So for example, if you have the integral, your limits are 3 to 6, and your constant is -4, then you would take your -4 and multiply it by the difference of 6 and 3. So -4 and 2. and negative 8. Now, note about the negative number. If I was asking for area, you would change that sign to make it positive. But here I'm asking for an evaluation, and there is a fine line difference between those, which we will go into in another lesson.